Right, as the light has faded and the sun has gone down below the horizon, I finally got the circuit set up, which is what we're here to see, isn't it? Not meant to talk about sunrises and sunsets in engineering videos, but there we go. Right, what have I got here? My voltmeter, this is measuring the voltage of my battery. There, my big battery, just to give some indication of what's going on. We've got my voltage divider circuit, which is connected to that big battery, that 12 volt car battery. We've also got some LED strip lights, which are connected via this cable here, via my CT clamp. And they can be controlled by little remote controls. If I switch them on, then we can see at 100% we pull in 2.6 amps. At 25% we pull in 0.65 amps. And at 50% we pull in 1.3 amps. So I'll turn those off for now. Okay, so my CT clamp is measuring that current, so it should be, fairly well. CT clamps aren't accurate, but there we are. We'll figure it out now. We'll see how accurate it is. The keen eyes amongst you would have noticed that I am now plugged in to my computer. So I'm using the USB. I'm not using the barrel jack, but when I take this out into the field, I will be using the barrel jack and not this. The reason why I'm doing that is because I want to display on my computer the voltage and the current for you, so you can see this whole thing working. And that's what we're going to do next. Well, this is the first real look at our code, isn't it? So here's our code, and I'm going to do a few things before we start. Check out A1 is where we measure our voltage. Yeah, that's right. These are the values of our resistors. I'll talk about that later on. This is our input volt. This is our voltage of our supply. I'll talk about that too. We've got 12.5. We've got A2, which is correct. Now, there's one thing I'm going to do. I'm going to set my current offset to 0 at the moment. And I'll tell you why in a bit. So this will upload this code. Okay, so my code's now uploading. It's uploaded. And this restart the serial monitor and see what we get. Well, okay, let's look at this. We're getting 12.5 volts measured from our voltmeter. And what are we getting on the screen here via the serial monitor? We're getting 12.84. So it's a little bit off. Okay, it's a little bit off. It's not perfect. We're also getting, according to this, a current of 4.83, and we can see that there's no load whatsoever. The LED light strips are off, so we need to put an offset. So we need to put an offset of minus 4.3 amps here, and re-upload the code. Minus 4.33 amps. And what that will do is it will artificially offset our value. So it will take 4.33 amps off the value here, which will set it to 0, hopefully. It doesn't always do it, which is really weird, because I thought things were meant to be logical. I thought electronics were meant to be logical, but they don't always work. There we go, we've set this to 0 now. Right, so let's turn on the LEDs. And what do we have here? So we're 50%, and we're reading 1.32 amps. And we're actually reading about 1.32 amps on the screen as well here. So that's fantastic. Let's go up to 100%. So we're reading. It's hard to see when this is on, isn't it? But we pulling in about 2.68 amps. And what does the serial monitor say? Well, it says we're pulling in about 2.73 amps, which is fine. Let's take it down to 25%. 0.64 amps on the screen there on the supply, and we got about 0.64 amps on the serial monitor, with our battery voltage measuring about 12.84. So we're a little bit off on the voltage measuring, which I'm surprised at. I thought we'd be more off on the current. This measures our power, so it multiplies the two together, and this measures our energy, multiplies it by a certain time. So that's it. That's the code working. So yeah, that's it working. I'm happy with that. Let's turn that off. What more can I say about this for now? Well, nothing really, except well, in the next section of this video, I'll put in an SD card and we'll log this data without the computer, and then we'll put it onto the computer and see what we get. We'll do a very similar test and see what we get. Okay, that's great. So in this test, I'm going to plug in my SD card here. And now I've taken the computer out, I've taken the USB out, and I've plugged my buck converter in. So I'm going to turn that on. Okay, that's on. Now, the Arduino's been powered up. Now, I know from experience that this isn't going to work because we need to press the reset button, basically. Once I press the reset button, I'm no expert on coding, right? I don't know how all this stuff works, but you don't just, well, I know a little bit, but I don't know a lot of it. I've tried to research this quite a bit. But you have to press the reset button to get it to log, and then that will start writing data onto the SD card. It won't delete data that's already onto the SD card. It will just add on to it if you have the file name created in the first place. So, okay, I saw the lights flash, and that means that we've now reset the SD card. Okay, so this should be working. This is basically independent of the computer. We've got our CT clamp on there. One thing I should mention is our arrow is going this way, so we're measuring that okay. If I switch it on, we should now, I think we log in every 5 seconds, so I'll leave it a bit. Now I'll go to, so we're pulling in 0.62 amps there. If I increase that now to 1.2 and leave it for at least 5 seconds. And now I'll increase it again, I'll leave it for another 5 seconds. And finally, I'll take it back down to the lowest, 25%. I can actually even go lower as well. Oh, what have I done now? Wow. Okay, I've changed the mode. I'm just going to turn this off. All right. Well, should we see what data we got on the SD card? So I'm just going to simply remove it. It's okay just to remove this. It's fine. All right, so I've plugged my SD card into the computer, and this is the file it's created. Let's see what it has created. Let's see if the real-time clock has worked. So this is data, actually, yeah, this is data from previous. I should have deleted all this, but it does go to prove the point, actually, that it doesn't delete the previous data, it just adds to it. So today we are the 30th of the 1st, and it is correct. It is 1656, although it's a little bit off. Now, look what's happened here. We've measured 12.45 volts, okay, and we're measuring minus 5.89 amps. Now this is an issue, right, that I really don't understand. I don't understand it myself. I've been through the code, and this shouldn't happen. Basically, we get different values from the serial monitor than what we get from the SD card. Now it should be exactly the same. I can't understand why it's not. I got a slight feeling why it's not, and I'll explain that when I go through the code. But what this does mean is that basically I'm more happy with the values of voltage. I mean, they're fine. I mean, you can't really like pick and choose, can you? You know, but you know which one is accurate and which one isn't. But this seems to be more accurate here. The current is way off, so I'm actually going to set the current to with an offset of 0 amps. So I'm going to come down here and I'm going to set this to an offset of 0 amps, okay. And I'm going to put this, I'm going to redo this. So I'm going to re-upload this to the Arduino, and then I'm going to do that test again. So here I'm plugging the computer back into the Arduino, and I'm going to re-upload the code. Now look, the serial monitor thinks we've got a current of 4.34, so I'm going to put the SD card back in, and we're going to see what it is now. And actually what I'm going to do is delete this. Move to trash, because I wanted to create this new file for us. I'm going to plug in the buck converter once again and turn it on. Arduino powered on. Put in my SD card. Press reset. Lights flash. Let's do the test again. Okay, so I plugged the SD card back into the computer and it's remade this file. I've told it to make this file. The code's told it to make this file. So this is where we were jumping around a bit, trying to play with the lights. And then I left it settle for a while. So we have the CT clamp thinks it's at minus 1.56 amps. So we'll put an offset, when this is at 0 I should say. So we're going to put an offset in of positive 1.56 amps via the offset here. 1.56 amps, and of course now I've got to plug this back in and upload it. Okay, put the SD card back in for the third time, and what have we got here? Well, this is where we had our 1.56 amps offset. I then at 0 amps, I then went into the software and put in an offset of this, and I took it down to 0 amps, which is great. Now this is measuring what we are seeing on the screen here, and at the end there this is where I turned off. So this is our full power, 50%, 25% and 0. So that's it. System is working. System is working fine. The trouble with the offset here is something which we'll talk about in the code, and you know, this is YouTube, innit? I'm no expert in this. I took a few months and I researched it and I found some code that worked, and I readjusted it and tweaked it, but it's not perfect and I can't get hold of the person who actually wrote it. So, and I'll explain who wrote it. Well, I'll tell you who wrote it here. It's a guy called Arduino, and I'm really, really grateful to this guy. And when it comes to talking about the code video, we'll talk about it. So if somebody, when I do go through the code video, has an idea of why the serial monitor is actually measuring differently or displaying differently to what the SD card is reading, then let me know, you know. Right, so I thought that was really good. That worked quite well. Let me know in the comments what you thought, and hope it all makes sense. I hope I haven't missed anything ridiculously obvious. Alright, cheers. Thanks for watching. Ta-ra.